The Chemistry Behind the Paint Mystery by Rebecca Liptrot, Georgia Beam, Daniela Castro, and Elli Kaplan.
Inorganic pigment versus organic pigment. Organic pigments are found in nature. Typically, organic pigments are derived from crushing dyes from plants. Organic pigments are typically more expensive than inorganic pigments. Inorganic pigments, or synthetic pigments, are synthesized chemically. These pigments are not found in nature. They are usually made up of metallic oxides. In our presentation, we will be focusing primarily on inorganic pigments. Following is a list of chemical compounds and the colors each creates.
Makeup of pigment colors. White is made up of titanium dioxide. Regular ground red is made up of arsenic trisulfide. Cadmium yellow is made up of cadmium zinc sulfide. Cobalt blue is made up of cobalt 2 chloride. Cobalt purple is made up of cobalt 2 phosphate. Burnt Sierra brown is made up of iron 3 oxide.
Of making paint. Paints have three basic components: pigment, solvent, and binder.
Of making paint. Pigment. Pigment is what gives paint its color. Many different colors can be made in many different combinations. We will explore the process of creating the Prussian blue pigment.
Making paint. Pigment. To make Prussian blue, iron 3 chloride solution is mixed with a potassium ferrocyanide solution.
When these two solutions are mixed, the reaction turns blue. We know a chemical reaction occurred because there is a color change.
Process of making paint. Pigment. The balanced equation for this reaction is iron 3 chloride plus potassium ferrocyanide yields iron 3 ferrocyanide plus potassium chloride.
Making paint. Pigment. Continued. Then the products are filtered so only iron 3 ferrocyanide, which is the Prussian blue pigment used in paints, is left.
Process of making paint. Pigment. Often, inorganic pigments are crystals of metal compounds. This is because transition metals have their valence electrons in the d orbitals. When the metal is bounded to other groups of atoms, this can cause the d orbitals to split into different energy levels. Electrons moving in between these levels as they gain then lose energy will emit visible light.
Process of making paint. Solvent. Solvent is used to reduce the thickness of paint for better application. Usually water is the solvent, but other organic solvents can be used. The amount of solvent used controls how thick or thin the paint is.
Making paint. Binder. A binder is a polymer whose job is to hold the pigment to its surface. Binders rely on cohesion and adhesion to work. We will be using three common types of binders: oil, acrylic, and tempera.
There are a lot of different types of paints, but the three we are using for our demonstration are oil paints, which contain pigments in linseed oil, mineral spirits, and a dryer; acrylic, which is a synthetic resin; and tempera, which is a mixture of egg yolk and pigment used in the 16th century.
The types of canvases. Oil canvas, used for when painting with oil-based paints. These canvases must be put in a drying room after use. Absorbent canvas, meant to be used with tempera, can be dried in a dry air oven. Universal canvas, intended to be used for both oil and acrylic paints.
How different types of paints react on different canvases. On the cotton duck canvas, acrylic is like a plastic paint, so it is very pigmented and looks good with any canvas. Oil paint takes longer to dry and does not look good on cotton duck. Watercolor spreads easily on this canvas because of the canvas's tendency to absorb water. In canvas, it is prone to expansion and contradiction due to the moisture, so it's the best canvas for all paints but is the most expensive. Oil shows up well and lasts longer because of its tendency to contradict and expand. Watercolor is water-based, so it is obviously going to look better with this canvas because of its contradiction and to moisture. On the watercolor canvas, it is only meant for watercolor.
Hey, so for our chemistry honors project, our interactive portion will be testing out different types of binders. The three binders we'll be trying out is acrylic, it's a very modern type of paint; oil, as in like oil paintings; and tempera, which is egg and water. It's a commonly known style before oil painting was created. For oil paint, we're going to be using flaxseed oil, which is also called linseed oil, and we're going to be using acrylic water-based paint. And so basically we're going to be putting our pigment in each one of these and trying them on 3 different surfaces of paper, glass, and tinfoil, and we're going to see which one does best. Okay, so I've just now finished stirring in the pigment to each one. Here's our acrylic, here is our oil-based, and here is the tempera or egg yolk. And so I'll be testing them out on each of our surfaces by creating one stroke, and we're going to see how each dries. Okay, so it's been a couple hours since I've done the strokes of each type of paint on each of the 3 surfaces. All acrylic, oil, and the tempera did well on the paper. On the glass, the acrylic is fully dry and had the best adhesion. The oil did not dry, and the egg yolk dried but was very blotchy and spotted. On the tinfoil, the acrylic dried and did really well. The oil dried but is very blotchy, and the egg yolk dried but is very blotchy. The reason for the acrylic paint for working so well is because acrylic has monomers which, when exposed to oxygen, go through a process of polymerization, and this helps bind the pigment to the surface. The oil paint, on the other hand, is a thick additive paint, which means that it absorbs oxygen from the air, and that makes it harden because enough oxygen will be absorbed into the oil until it becomes almost solid. From this process, it usually causes a crackling effect. This will be apparent in very old oil paintings because the layer of paint is too thick, and so it will dry at different rates, causing this crackling effect. From our findings, we can conclude that acrylic binders are better than the less modern versions of tempera and oil paint.